We're living through this quiet revolution, and it's changing everything. I mean, everything, from our money to our very own biology. It's like we've moved past just coding for computers. Now, we're starting to write the code for creation itself.
Okay, so let me ask you something. What do a 66% annual return, a factory car that drives itself, and, get this, lab-grown coffee all have in common? I know it sounds like the setup to a weird joke, right? But the answer? Well, that's the thread that connects this entire story.
They're all part of this quiet revolution. See, we're learning to program our world. It's this simple but incredibly powerful idea. We're not just programming computers anymore. We're taking the logic of code and applying it to, well, everything. Our markets, our machines, and yeah, even to life itself.
So, where did this all start? You'd probably guess it was with some fancy robot or in a high-tech biolab. But actually, it all kicked off in a world of pure data. Finance. The very first thing we really learned to program wasn't a machine. It was the market. Just look at that number. 66%. That was the annualized return for Jim Simon's Medallion Fund for 30 years straight. To give you some perspective, that absolutely leaves legends like Warren Buffett in the dust. So how on earth did they do it? Well, they didn't try to outguess the market with hunches. Nope. They treated it like a giant, complex system, one that could be decoded.
A big part of their secret sauce was something called factor investing. So instead of betting on one company's story, the way most people do, they hunted for these underlying characteristics or factors that are just consistently linked with higher returns. Things like a company's size, its value, its momentum. These became the variables, the rules, in their investment code. They weren't using gut feelings, they were literally running a program.
Okay, so programming markets, that's one thing. It's all just data, ones and zeros floating around in a computer. But what happens when that same logic breaks out of the screen? What happens when it starts to program the physical world? The world of actual atoms. And this quote from Deloitte just hits the nail on the head. Intelligence isn't just stuck on screens anymore. That same kind of pattern-finding brain that cracked the stock market is now being put into a physical body, giving it the power to move, to sense, to actually change things in the real world.
And listen, this isn't science fiction. This is happening right now. Just think about Amazon's warehouses. They've got over 1 million robots, all coordinated by a central AI, basically turning the entire building into one massive thinking machine. Or how about this? In BMW factories, brand new cars are literally driving themselves along kilometer-long production lines. We've moved beyond programming one robot. We are programming entire factories.
But it gets even crazier. It goes deeper than just programming machines. We are now starting to program matter itself. Seriously. Look at batteries. For ages, we've kind of been stuck, hitting a ceiling on how much energy we can pack into them. But by completely reprogramming the materials inside, these new solid-state batteries are on track to almost double that capacity. This isn't just a small improvement, it's a total game changer for how we build stuff.
So, we've gone from programming markets to programming matter. What's left? What's the final frontier? Well, it's the most complex, the most elegant, the most mind-bogglingly intricate system we know of. Life itself.
Jennifer Doudna, one of the pioneers of CRISPR, really said it best. The ability to edit the source code of life, it's not some far-off dream. It's here, right now. So the question isn't if we're going to use this power anymore. The real question is how. And believe me, the answers will change everything.
And the tools we have for this? They're getting better at an absolutely insane pace. First, we got CRISPR. Think of it like a pair of molecular scissors that can cut DNA. Then came base editing, which is way more precise. It's like having a pencil and an eraser to change just one single letter of the genetic code. And now we have epigenetic editing, which is like finding the light switches for our genes, letting us turn them on or off without changing the code itself. The level of control we're getting is just incredible.
So what's pouring fuel on this fire? What's driving this incredible explosion of progress? You guessed it, AI. I mean, biology is just this massively complex system, right? Almost infinitely so. But AI is finally giving us the key to unlock its secrets, to finally decipher its language.
And the impact is already gigantic. We're talking about things like Google's AlphaFold, which can basically predict the 3D shape of pretty much every protein known to science. We're talking about drug companies using AI to design brand new medicines from scratch. It's a huge leap. We're not just reading the code of life anymore. Now, with AI's help, we're starting to write it.
So let's just step back for a second.
What does a world actually look like when we can program biology with this kind of precision? I mean, what kind of future are we actually building here?
Well, for starters, it could be a world where your clothes fix themselves. No, seriously. Imagine having bacteria engineered and woven right into the fabric. You get a tear, and they just wake up and start growing new fibers to patch the hole. Wild, right?
And it gets bigger. We're talking about tackling climate change on a planetary scale. We could engineer bacteria to supercharge natural processes, basically turning entire rock formations into massive carbon sponges, pulling CO2 right out of the atmosphere.
And then there's the really personal stuff. It could be a world where organ donor lists are just a thing of the past. A world where, if you need a new kidney, we could just take your own cells, use a bioprinter, and grow you a brand new one, perfectly matched, no rejection, on demand.
The possibilities are, well, they're just breathtaking. But, and this is a big but, with this incredible, almost godlike power comes some of the biggest, toughest questions we have ever had to face as a species.
You see, for every amazing opportunity, like finally being able to cure horrible genetic diseases, there's a massive challenge right next to it. How do we make sure everyone gets access to these cures, not just the wealthy? How do we even begin to regulate human gene editing? How do we stop this from being misused? And what about the things we can't even see coming? Like, I don't know, ancient viruses waking up from melting permafrost?
And that really is what it all comes down to. We are learning to program markets, matter, and life itself. We are becoming the architects of our own reality, finally getting our hands on the source code. So for the first time, maybe ever, the most important question isn't, can we? It's, what should we create?